Okay, so hello students, my name is Vinod Kumar and today we will study projectile motion. Okay, so in classical mechanics, basically we read this topic or we can say we study this topic, and in this topic, what we will study is the we can say the phenomena about the projectile motion. Basically, where do we see projectile motion? When we throw a ball, or we can say when we throw a football, or when we launch a rocket, then the projectile motion is has been observed. Okay, so basically, when we throw any ball, or we can say any football in the air, or we can say in the vertical direction, then what happens? Initially, we give some velocity to that ball, and then after some time, that ball goes in the air and it reaches some height, and after that, it again come to the ground. Okay, so that kind of motion is called as projectile motion. Okay, and the path it takes is called as projectile path, or sometimes the path is called as trajectory. Okay, and we will see that what is that path is named as. Okay, and after the conversation we will see that that path is called as basically that path will be the type of path will be uh, we can say the parabolic path. Okay, that we will see later on. So first of all, we will start with our topic, projectile motion. Okay, let me start. Projectile motion. Okay, in projectile motion, first of all, we will write some examples. Examples like we can say throwing a ball, or we can say kicking a football. These kind of examples we can see. Okay, and now what we will see the graphical representation of projectile motion, so that we will get some mathematical expressions to, we can say, that can be used for further analysis of the projectile motion. Okay, so we will select here a coordinate axis, or we can say coordinate set, that will be xy. So xy coordinate system we are going to use. So vertical axis will be y axis, and 1 second, and the downward axis will be, the horizontal axis will be x axis. Okay, and now we'll assume that we have one projectile, or we can say some particle or some object that we are going to throw, for example. So that is initially at this point. Okay, and now we are going to throw it. So initially the particle is at here at this point, or we can say at zero height from the ground, and now we are going to throw it. Then it will trace a path like that. So this kind of path it will trace. Okay, and we'll see that why this kind of path it will trace, that we'll see, that we are going to see by using the equations. Okay, and here we are assuming that we are throwing that particle, or we can say that projectile, with initial velocity u. Okay, so we are going to mention that velocity. Okay, so now we are going to represent that velocity by some, well, sorry, that velocity vector u, initial velocity. Okay, again it is drawing like that. Wait. Okay, so this kind of initial velocity we are going to give, and it is making angle theta with the horizontal axis. We are assuming that the velocity u is making with horizontal axis, we can say it is theta angle. Okay, now we are going to determine the x component and y component of the velocity, the initial velocity. Fine. So the x component of the velocity will be basically it will be ux equals to u cos theta, this component u cos theta, and the y component will be u sin theta. That we all know from the mathematical property of the, we can say, uh, trigonometric properties. Okay. Now uy will be u sin theta. Okay. So now our first task is done, that we have calculated here the horizontal component of the initial velocity and the final, the, we can say, vertical component of the initial velocity. Now what we are going to do, we are going to express our equations, or we can say Newton's equations of motion in x direction and in y direction. And then later on we will see that what are our equations for the x-axis position, or we can say x-axis component of the position, and y-axis coordinate of the position of the, or we can say the position of the particle at a time t, that we are going to see. Okay. So if I see at this point, there will be two components now that we have drawn here, that is u cos theta, and the vertical is u sin theta. Wait, u sin theta, and the velocity is u at this point. Okay, so that we have already done at this point also. So for your better understanding, we are doing at another point. Fine. Now our task is to implement the Newton's equations of motion in x direction and in y direction. Okay, so we'll start doing that. So first of all, we will use Newton's second equation of motion, because we are going to find out the coordinates of that projectile at a time t. Okay, so at this point we are going to find out, for example, at this point, so here the coordinates, they will be x comma y. Okay, so now what we will do, using Newton's second equation of motion. Second equation of motion. What is Newton's second equation of motion? That is s equals to u times t plus half at square. Okay. Now what we are going to see, we are going to see these equations in the x direction and y direction. So first of all, in x direction, okay, x direction, or we can say horizontal also, horizontal direction. Fine. In horizontal direction, the s will be equals to x, because we can see here the s is the, we can say, distance traveled. Okay, so the distance traveled in the x direction is x, and now whatever is the thing in the, now in the equation, what we are going to see, wait, okay, in equation the another thing is velocity. So velocity in the x direction is ux, and that is u cos theta, and the acceleration in the x direction is 0 meter per second. Okay, that is important. The, well, we can say acceleration in the x direction, ax equals to 0. Why it is 0? Because we know that when we throw any projectile in the upward direction, there will be only acceleration in the vertical direction. There will not be any acceleration in the we can say, horizontal direction. Okay, because the whatever thing is, because the particle is going in the vertical direction only, and after some time it is reaching to the ground by using the horizontal vertical direction. So that's why there is no we can say, no acceleration in the x direction, and there will be only acceleration in the y direction. And what is the name of that acceleration in the y direction? That is acceleration due to gravity, or we can say g. Simply, it is 9.8 meter per second square that we are going to use. Okay, so what the equation becomes in the x direction? So the equation will be basically, it will be, sorry, it will be x equals to ux into t plus 1 by 2 ax t square. Now we will put the values. Ux is basically u cos theta, and the t is the time, plus 1 by 2. Ax is 0 into t square. So the equation will become x equals to u cos theta into t. Okay. From here, we will find out the expression for time t, that is u x upon u cos theta. Okay. And we will name this equation as one second. Okay. Now we will name the equation as this equation as equation number 1. Okay. Because we are going to use this equation in the next section. So now our task is to implement the Newton's second equation of motion in the y direction. So our second task is in y direction. What is the equation of motion? First of all, the equation of motion will be y equals to uyt plus half ayt square, right? And now we are going to see that what are the values for uy and what are the value for ay. Okay, so here uy equals to, what is uy that we already done? Uy is the vertical component of the initial velocity, that is u sine theta. And what is ay here? Ay is minus g. Why it is minus g? Because we know that the acceleration due to gravity is in the downward direction and the particle is moving in the vertical direction, in the upward direction. So that's why the acceleration due to gravity we have to take is negative. Okay, now we'll put this in the equation. So what we will get? Y equals to u sine theta into t plus half. In place of ay, I have to write g into t square. Okay, so this is the equation. Now from equation number 1, we will substitute the expression for time t. Okay, so what is our equation number 1? T equals to x upon u cos theta. So that I'm going to substitute in this equation. So now substitute expression for t from equation number 1. From equation number 1, we are going to substitute this. Okay, so now the equation will become as y equals to u sine theta, and in place of t, I have to write x upon u cos theta minus, because this minus plus into minus sign will become minus sign. So it will be minus half z into, in place of t, I have to write x upon u cos theta, and because there is a square, so we have to square it also. So this will become y equals to, here what we can see, the u and u will be cancelled out. Now the equation will become as x into sine theta upon cos theta minus z by 2 into x square upon u square cos square theta. So this kind of equation we are getting. Now we'll solve it further, that what kind of equation we'll get at the end. So it will be y equals to, what is x into sine theta upon cos theta? As we all know that sine theta upon cos theta is tan theta. So we'll write x into tan theta minus 1 by 2. And here what we are going to see, gx square upon u square upon cos square theta. So we will write here gx square upon u square cos square theta. So this is the final equation for, we can say, the particle at a time t where the x and the y coordinates are interrelated with each other. Okay. So let me box it. Okay. And as you can see, this equation is nothing but it is the equation of trajectory of the projectile. This is the equation for trajectory of the projectile. Okay. Now for our first task is done. We have determined the equation for x coordinate and the y coordinate both of them, and the relation between y and x also. Now we are going to see that what type of path it will make, because as we can see, this equation is nothing but it is an equation of parabola. And parabola is nothing but it is around x-axis, because we know that the equation of parabola is because y equals to a times x minus h whole square plus some constant k, that is the equation of parabola, है ना? So that's why we are saying that the trajectory is parabolic. That's why we can say that the trajectory is parabolic. Parabolic in nature. So the nature of the and we can verify it also by the diagram also, because it by the we can say the picture also, it is clear that the path is parabolic. The path of the projectile is parabolic. Now the few things we are going to derive is, first of all, what we are going to derive, the time of flight, and the second thing we are going to derive is the maximum height obtained by the particle, and the third thing is range of the particle. And we are going to see their definitions also, that what are their definitions. So first of all, we will start with time of flight. Okay, so our next topic is time of flight, and basically it is denoted by capital T. In most of the textbook you will see that it is denoted by capital T. So what is time of flight actually? Time of flight is the time taken to the time of flight is basically the time taken by the projectile from the initial point to the final point. Okay, initial point will be the from where we have launched that particle, or we can say thrown that particle, and the final point will be where again it will go to the same ground. So the time taken to complete the path is, that is the time of flight. Okay, so we are going to see it, and which equation we are going to use here is, first of all, we are going to use here the equation. Okay, I'm going to see. Okay, so here we are going to use equation in the Newton's first equation of motion. Okay, we are going to use here. Okay, so by using Newton's first equation of motion. What is the first equation of motion? It is basically v equals to u plus at. And now we are going to use it in the which direction? Y direction. Because in the x direction, if there is no acceleration, so the velocity will be same throughout the motion. So we'll write here in y direction. So in y direction, the velocity will be going to written as Vy, and it will be Uy initial velocity plus Ay into t. This will be the equation of motion, first equation of motion in the y direction. Okay. Now what we are going to see, we are going to, we can say, divide our total project, we can say projectile path in two parts. Okay. So I'm going to see in which two parts. First of all, here at this point, this will be the point of maximum height. Okay. And now let me draw it again so it will be easy for you to understand. Wait. Y direction, and it was our x direction. And sorry, it is small. So let me draw it some bigger path. Okay, so the path was like that. Okay, assume it as parabolic. Okay, now our task is to divide this in two parts. Two parts. So first of all, this part, and from the initial point to, there will be 3 points on. So initial point to the point of the maximum height. So this point will be, this point will be basically it will be maximum height point, and basically it is written as S maximum. So the time taken here to reach the point maximum height will denote it by t, small t. Okay, and the time taken again from this point also the similar path is there, so it will be going to take the same time t. Okay, so to reach the maximum height, what we are going to say, we are going to write here, to reach the maximum height. So if it will achieve the maximum height, if it will achieve the maximum height, so at this point I am saying, so at this point what we are going to see here, there will only be which velocity? Velocity in the x direction only. Fine. There will not be any velocity in the y direction. So here, Vy will be 0 at this point. So we are going to take this in consideration for in the above equation. So our equation will become, okay, so our equation will become 0 equals to uy is u sine theta minus g into t, because in place of ay we have to take minus c. Now this equation will become gt equals to u sine theta. Okay, now the time will be u sine theta upon g. This is the time taken to achieve the maximum height. Now the total time of flight. Now the time of flight will be, now the time of flight. So that will be 2 times t. Fine. So it will be t equals to 2 times t, because this is the time taken by the particle to achieve the maximum height. Now from that maximum height, it will going to the ground with the same time. So it will be t equals to 2u sine theta upon z. So this is our total time taken, or we can say the time of flight. Okay. Now our next topic is maximum height. Okay. So maximum height, or sometime it is written as height of, sometime it is written as height of projectile. Okay. So now we are going to use the equation. One second. Let me see. Okay. We are going to use this equation. Okay. Y equals to u cos u sine theta into t minus half gt square. This equation I am going to use. And we'll put the time period here, and then we'll determine the maximum height. Okay. So we are going to use that equation again. So let me write it. It was y equals to u sine theta into t minus half gt square. Now at maximum height, y equals to h max, or time t is, because we know that still we are not going to take the total time of flight, because that is time for the whole projectile, or we can say the whole trajectory. We are going to take which time to achieve the maximum height. So that is t equals to u sine theta in upon g. Now we are going to put this in the above equation. So equation will be s maximum equals to u sine theta, and in place of t we have to write again u sine theta and upon z minus 1 by 2 z into u sine theta upon z and its square. Okay. So the equation will become as, the equation will become as, one second, wait. Okay. So the equation will become as h maximum equals to u sine theta into u sine theta. It will be basically u square sine square theta upon z minus here u square sine square theta. So we are going to use z into u square sine square theta upon 2z square. Okay. So from here, what we can cancel this z and the square. There will be only z. So the equation will become as maxima equals to u square sine square theta upon z minus half u square sine square theta upon z. Now you can see u square sine square theta upon z. This term is common in both the terms. Okay. So here 1 minus half will be half. So the equation will become as, the equation will become as what? It will be u square sine square theta upon 2z. Let me write it. Okay. So h maximum is u square sine square theta upon 2z. So this will be our equation. Wait. And sometime it is written by just capital H also. So that is also fine. because if someone will say that it is not maximum height, it is the height achieved by the particle. It is not the maximum height, because the maximum height will be depending on the value theta. So that is the another case. We are not going into that, because that maximum height will be when the theta is 90 degree, because the sign will give us the maximum value at sine 9, we can say sine 90 degree. That is one. That is the another factor. So let's not go into that, we can say, confusion. So let me write it again as h equals to u square sine square theta upon 2z. So the equation is basically the same. So this is the equation of maximum height that we obtain. So now what we time of flight we have done, and the maximum height we have done. What is left? Range. Okay. So the range is very easy to determine. So we'll do that. One second. Okay. So our next topic is range of the projectile, and it is written by capital R. Okay, it is written by capital R, that we are going to derive. So again, if you want to see how the range looks like, it will be basically, okay, wait. So it will be the horizontal distance, okay, that we are going to see. This horizontal distance traveled by the projectile is named as range of the projectile, okay, y-axis, x-axis. So that is basically, if we apply what we can see, Newton's first equation of motion in which direction? In x direction. So if we apply in the x direction, it will be basically Vx equals to ux plus ax into t. Since we know that ax equals to 0 meter per second square, so that's why, so the Vx will be ux plus 0 into t, or we can say Vx equals to ux equals to u cos theta t. That is the same, we can say, initial initial x component of the y x component of the initial velocity. So that's why we can say that velocity in the x direction is not going to change. If it is not going to change, then we can say that it is not depending on the other factors. So what we will do, we will directly use the formula of nothing but uh, speed, or we can say velocity, that is distance upon time. Okay, so we are going to determine here the distance, the horizontal distance, this one, the horizontal distance we are going to find out. So that will be uh, the velocity into total time taken by the projectile to cover the path. Okay, so that will be basically r equals to, okay, now range is nothing but r equals to, it will be velocity into total time. Velocity in x direction only, okay, not in the y direction. So it will be r equals to ux into capital T. That capital T is the, as we have derived, it is nothing but time of flight. Time of flight. So r will be ux is that we already know that ux is u cos theta into total time of flight is nothing but it is 2 times u sin theta upon z. Now let's multiply u into u will be u square and it will be 2u square cos theta into sin theta upon g. This will be the equation. And if you want to solve it further, then what we can write here? We can write here because as we know that 2 cos theta into sin theta is nothing but sin 2 theta. From the mathematical property, or we can say mathematical trigonometric property, we can write it. Okay, so now the equation will become as r equals to u square sin 2 theta upon g. So this will be our final equation for the range r. Range r of what? Range r of the projectile. Okay, so it is the equation of, wait. Mm, equation of range. Okay, range of the projectile. So here, let me summarize it. We started with the projectile motion of the particle, and in this projectile of the particle, we started with the coordinates of the particle, that is x comma y, and we derived equation for the x and y, where y, the relation between y and x was nothing but the equation of parabola. So that's why we named that the trajectory of a projectile is nothing but parabolic. And then what we derived? We derived the total time taken by the projectile, that is called as the time of flight. And then we derived equation for maximum height, and then we derived the equation for range of the projectile. So I hope you understand this well. And if you have any doubt, then you can share your doubts in the comment section, and I'll be happy to answer that. Okay, thank you so much.